0.
Here we go, section 7.4, when we are trying to expand, what? Hold on, expand, hold on. Wasn't expand something to do with, I don't know, logarithms? Why am I bringing up expand? Well, kiddos, what's the whole point of section 7.4? Is to take something that has been condensed and go the other way. How is it condensed? By common denominators. So condensing would be taking two separate fractions and condensing it down into one with common denominators. And some of you are remembering this from, ironically, trig and t proofs. But really it's just the good old-fashioned common denominators. However, that's something from the past. What are we doing that's new? What's the other way, the other direction called?
The future.
The future. What's the other vocab besides condense?
Oh, expand.
Expand. That's hilarious. Expand.
Yeah.
And we're going to expand by partial fractions. And so remember last time I said just write down the key categories and maybe the formulas, right? And then I said, hey, look, this is me summarizing the key categories. So number one, if I were you, when you wrote divide when improper, I would show if the degree of the numerator is greater than or equal to the degree of the denominator, we call it a top-heavy or an improper fraction. It's not about how many terms. It's not about how big the numbers are. It's all about the degree. So when the top wins, we say we can divide that. The first step in breaking it apart into its simpler pieces, expanding it, is to do polynomial long division. Once we have polynomial long division, then we say, is there anything left in a fraction? If there is, we take whatever's left and we break it down even farther. Further is better because farther is a distance. And then we go through the entire process of finding partial fractions. So finding partial fractions is technically just steps 2 through. I just call them partials. No, that's not very precise. Partial fractions. P.S. Happy Monday and all that jazz. You guys know I love you. I just need to get going because we have barely any time today, right? So, finding partial fractions, we factor first. Once we're in this whole partial fraction, we have this guy as a proper, no longer top-heavy, been divided if he needed to be. Factor the denominator first. And then we look at the factors. If we have linear factors, if we have quadratic factors, well, this is what it looks like. If we have linear factors. Quick example could be something like, oh, I don't even know. 1 over x plus 3 times x minus 5. Or quadratic could be something like 3x plus 1 all over x plus 5 and x squared plus 7. Repeated could be something to the effect of 7 over x minus, I don't even know, 6 times x plus 1 squared. Okay, let me go ahead and show you guys what's going on in each of these. Linear. I have a linear here and a linear there. Quadratic. I have a quadratic here that cannot be reduced down anymore. It's called an irreducible, if you guys remember that from the past. Repeated, what if I have something squared? Now each of them I've tried to kind of build on it so it's not like totally just linear, just quadratic, just repeated, but it's like, hey, now quadratic has been brought in, now repeated has been brought in, what changes, what's new? So my illustration, if we were to form, I think this is what WebAssign would say. If we're just trying to form the partials, like it doesn't say to solve, but to form, people that have gotten into WebAssign, I'm going to look for your input in just a second. But I think it's form, not solve. To form the partials, for the first one, we would have a over x plus 3 plus b over x minus 5. To form the next one, we would have a over x plus 5 plus bx plus c over x squared plus 7, that's a plus, The last one, we would have a over x minus 6 plus b over x plus 1 plus c over x plus 1 squared. My question to you is the following for each one. But let me take a breath. Let me give you guys a chance to catch up on the writing. I'm curious as to what you see. Don't answer yet. I'm curious as to what you see regarding as something new gets introduced. I'm curious as to what you see as something new gets introduced. Is different. No, not new or different. Hold on. What stays the same? Kiddos, every time you have a linear factor, hold on. Who is a linear factor?
First bottom denominator.
Bottom denominator is what?
X plus 3.
Yeah, hey, a line. Help me out. You guys know more than you think you do. What's the simple equation of a line? Y equals what?
X plus B.
Nice. Guess what? Algebra 1A has a test on this on Thursday. But yes, y equals mx plus b. What's the degree of x in a line? 1. What's true about the degree of x in x plus 3? 1. What about the degree of x in x minus 5? 1. How about x plus 5? 1. X minus 6? 1. X plus 1? X plus 1 before the squared? Before the squared. 1. What do you notice about every single numerator for every single linear factor? Do you see it? They're all what? Well, actually, you don't know. Good thing to bring up, though. I haven't put a negative by any of them, but by it being an unknown, couldn't A, B, C, couldn't they be positives or negatives, technically? Okay, so just realize there's no, like, written negative, but it could be negative, but what's even... Maybe it's not simpler than that, but even more basic than that. What's above any linear? There's only one unknown, right? It's an A, it's a B, it's an A, it's an A, it's a B, it's a C. Anytime I have a linear factor, all I need to do is put A, B, C, D, whatever comes next in order, and here's why. If this is on the denominator, and if I have a proper fraction, proper meaning not top heavy, what degree does the top need to have? If it's a proper fraction, a linear is on the bottom. What's the only possible degree on top? Yeah, it has to be smaller because what does it take to be improper? Greater than or equal to. So can I have an x on top? If I had an x on top, wouldn't the degrees be equal? That's improper. You see it? If I had an x squared, well then it's definitely improper, right? So then, well, if I can't have an x, and if I can't have an x squared, if I can't have an x cubed, what's the only thing, yeah, perfect. What's the only thing that can be on top? And x to the 0 is just the same thing as 1. I can have that times any number. All I can have is a constant. All I can have is a constant. Now, what changes when I have quadratic? Well, the linear guy stays the same, but what's new? Wait a minute. Why can't you factor x squared plus 7? I thought we could do like x plus square root of 7 and x minus square root of 7. No, a plus times a minus would be a what? Yeah, you guys tracking with that? X plus rad 7, x minus rad 7. Would that give me an x squared? Yes. Would that give me a 7? Yes. Would that cancel the outer and the inner? Yes. But what would the sign be? Minus. That's not the factoring. I can't break down x squared plus 7. If I was looking for solutions like the factors, wouldn't I have a square root of a negative number? Is that real? No. So if I wanted to keep going, they would be what we call imaginary, right? We're not looking for those imaginary ones. We're looking for the real ones. And if we're looking for the real ones, well, I can't factor it down anymore. So if I have, ready, keyword, irreducible. I can't go factoring anymore. It'll almost always be like an x squared plus something. Yeah, if it's x squared plus something, I can't factor. X squared plus a constant, I should say. So what did you notice that changed? Right? What did you guys notice that changed for the quadratic? But why are there two? Because to be proper, right? To be proper, if I have some sort of x squared plus bx plus c, I can have more than, right? I can have more than just a constant. I can also have a linear piece and it would still be proper. So I have to leave room for anything that could be up there. I can't go to a quadratic because then that would be improper. But the formulaic way or the system of making a partial fraction is just make room for a proper partial fraction, which means take it down 1 degree. There you go. And just keep going in alphabetical order. So what's the only new different thing with repeated? What do you notice with this guy?
It's squared on the outside, so it makes it like another, like it has another,
It has a whole, yeah, do you see it? It has a whole extra term, right? For quadratic, I have an extra part in my numerator, and for repeated, it's like, well, I have to leave room for, technically this could have been multiplied by x plus 1 squared to get a common denominator. This could have been multiplied by one of those and one of these to get a common denominator, and this could have been multiplied by that guy to get a common denominator. Any of these could join to make that. I just have to make room for it. But guys, after that, it's just let's play. Is that cool? After that, it's just play. So I want you guys to go ahead and, first of all, form the partials, which is exactly what I just did. And anybody who's gotten into WebAssign, how gorgeous is the form the partials questions? A lot of work or a little bit of work? Little bit of work. We like those. But after we form the partials, guess what? We are going to solve for the partials. I'm going to show you both. Forming the partials and solving for the partials. Form the partials first. Factor that denominator. Ask yourself linear, quadratic, irreducible, repeated. Form your partials. It can be now or it can be at the end. Whichever one works. All right, so as you guys were forming your partials, my question was, or is, did you figure out that we are trying to make an A and a B? Solve for an A and a B. What are your denominators, cool kids?
x minus 3 and x plus 2.
My strong advice is to go ahead and rewrite. I know some of you are like, she's just wanting us to do extra work. It's rarely, if ever, my motivation. There is a purpose to rewriting the original. Wait a minute, how did I rewrite the original? Why did I rewrite the original? Because I'm trying to take this and break it down into that, and so to solve. Now, if it just says to form the partials, you're done. Isn't that the beginning of homework for at least a few, right? Oh, for those that have, there's head nods. Yes. Beginning of homework is just write the or match the partials. But what if we are supposed to keep going? Partial fraction, decomposition, decomposing, breaking apart, expanding. All similar idea. How do I keep going? Multiply to reduce away all denominators. If I want to get rid of all the denominators, am I just going to multiply by that? Nope. Just multiply by that? Nope. What am I going to multiply by? Everybody. Everybody gets the whole denominator. And once you get the hang of it, I'm ultimately just multiplying the division on the other side. But once you get the hang of it, you're like, oh, that whole thing's gone. That's nice. Oh, you take away that one, but you're left with the other one. You take away that one, but you're left with the other one. And all that's left over here is the numerator. It's as simple as get rid of the division, take the bottom, multiply it on the other side. But what we're doing is we're reducing away all the denominators, all the division. How are we doing? We okay?
Yes, very good.
You now have 2 routes forward. Doesn't make a big difference on this one, but it's going to make a big difference on some of the messy ones. One is two routes forward. One is one that you saw from me last time, and the other one is like a, oh, this can be handy sometimes. One is something that you saw from me last time, and one is a, oh, this can be handy sometimes. The first one says, separate by terms. What? Separate by types of terms. Huh? Separating by types of terms says, you have a 1x that must come from an ax plus bx. Separating by terms says, I have a 1x that must have come from an ax and a bx. The only way to get a 1x, the only way to get that x term to be what it is by combining the x terms over here. An x term comes from x terms, and a number is going to come from the non-x terms. Actually, it's not a plus, it's going to be a minus. So I separate my variable terms from my constant terms, or my non-variable terms is usually the easier way of looking at it. Variable as in, hey, I have a 1x here, and that comes from an ax and a bx, versus a 7 that comes from a 2a and a negative 3b. Go ahead, Jackson.
I wasn't asking.
Oh, go ahead, Andy.
Oh, so you just distributed it and then separated it, right?
Exactly.
That's okay.
Exactly. By type of term. You see it? How'd I group them? Say it one more time. Yeah, quite literally. I distributed and then I grouped. And I said, you are the x's, you're not the x's. Oh, x's and not x's. And what was the purpose of that? Because I can say, hey, divide everything by an x, and now what do I have remaining? I have a system of equations. They both need to be true, and so I can go ahead and think of something like, how about making this my R1 and making this my R2, and why not do something like negative 2R1 plus R2? You guys want to see the math? I'm going to multiply this whole guy by negative 2. So I get negative 2 equals negative 2a minus 2b plus 7 is equal to, hey, what am I using from this chapter?
Elimination.
Elimination, because I'm like, oh, if I just make the a's match. Now I'm kind of simplifying and doing some of this a little bit fast, but I'm just saying, ooh, that's an equation and that's an equation. And once I got rid of the x's, I have a's and b's, I can solve it. Because then my a's go away, and I end up with 5 is equal to negative 5b. So therefore, b is equal to negative 1. In any system of equations, what do we always do once we have one? Back substitute. This is a nice one to back substitute in. 1 is equal to a plus b, which is a minus 1. So then a is going to equal, add 1 on both sides, 2. And I have my final answer of 2 over x minus 3 plus a negative 1 or minus 1. Either way works. Could these be written in different orders? Yes, because addition is commutative, but the negative 1 better go with that x plus 2, and the 2 better go with that x minus 3. But some of you might be asking, so what's the other way? Some of you might be asking, so what's the other way? The other way says, well, what if I was to do this weird plugging in thing? And the strategy of what to plug in is we look at the zeros. And so the zeros of, for instance, this guy, the 0 would be x equals negative 2. And the 0 of that guy would be x equals 3. Using the zeros, x equals negative 2 and x equals 3. What would happen if I plugged in x equals negative 2 to this equation, this whole equation right here, this whole thing? If I plug in x equals negative 2, I would end up with the following. Negative 2 plus 7, everybody. Isn't that 5? My a is still an a, but what happens when you plug in the 0, negative 2 plus 2? What happens if that whole thing is 0? It's going to go away. Anytime you plug in a 0, it cancels out something. Ooh, I like where this is going, because what's negative 2 minus 3, everybody? Negative 5. It's a strategy. It's a shortcut. It's still doing this system work, but in a faster way that says if you plug in a 0, and if this equation has to be true, you're going to lose one of your variables. And guys, what's 5 divided by negative 5? Isn't that what we found up above? Ooh. I find a 0, and I plug it in all the way across. And that was 1 0. What do you think is going to happen if I plug in the, what's the other 0? I mean, you know what sometimes means. You just don't like what it might mean.
When does it not work?
3 plus 7 is 10 equals a times 3 plus 2 is 5 plus b times 3 minus 3 is 0. Ooh, I love it. What's the a going to be? After the 0 goes away, doesn't a equal? Do we like it? So back to Natalie's question. Why sometimes? Question. Who does not have a 0 of the examples on the screen? Who does not have a 0 of the examples on the screen? He has a 0, negative 3. He has a 0, 5. He has a 0, negative 5. He has a, what's true about irreducible zeros? That's when it gets done. You can only use the zeros trick if there are zeros. Now, technically, I actually can expand this and say zeros and or strategic x values. But then it's just not quite so sweet. I can say zeros and or strategic x values, but it's not quite so sweet. However. This is a nice one, but you guys don't want us to spend our last few minutes on nice ones, do you?
Oh my god.
Alright, let's see. Okay, I changed my mind. Let's do this one next. It's proper. Oh, poor Michelle, someone help her out. It's proper, right? Okay, so check it. Very first step is to form the partials. Help me out. Form the partials. We love these ones. You don't have to solve. What happens when you guys factor? Why'd she make it so much longer over there? Ooh, we pull out an x. That's linear, right? Dun, 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 dun. But what's left when we pull out an x?
X squared plus 4.
It's irreducible, which means I need a ba-ba-da-ba-da-ba-da-ba-da. Now, take that guy, write him down. If I was forming my partials, I would be done. But if it says to solve, I gotta keep going, right? How do you keep going? Multiply. After multiplying, you would land with 3x squared plus 4x plus 4 equals a times the other guy, plus bx plus c, don't forget your parentheses, times the other guy. If we were going to do the first step, or the first route of solving, and if we were to group by terms, do you guys see how many different equations we would have? We would have a system of 3 equations instead of 2 equations, which is like section 7.3. So, wasn't there another way?
Zero way?
The zeros way. But didn't I just say there are no zeros of this guy? So careful. I said zeros and or strategic x values. And by strategic, I just mean easy. What? Well, guys, what's the zero that I do know?
X equals 0.
Okay. So if I used x equals 0, and then if you had to plug in something, what's something easy to plug in?
0.
But we're already doing that. Something else? Oh, nice.
Panda.
And now, well, how many unknowns do I have? I need 3. I need to match it. I need 3 plugins for 3 unknowns. Kind of similar to how we would need a system of 3 equations. Do you want to go to a -1 or a 2? It's up to you. They're both strategic in different ways. One stays positive, one goes negative. Just choose one. Choose one.
2.
Okay. We need to get out to chapel. But I'm going to finish this on the Jamboard during nutrition, I hope. It works. It just doesn't land you directly in the answers. It lands you in one answer that we then plug in, and then it lands us in a smaller system of equations with 2 equations, 2 unknowns. It's better than 3 equations, 3 unknowns. Guys, we'll reevaluate tomorrow. I'll be reasonable. We'll see. We'll see. Is it due today?
It's due
Oh, it was supposed to be due tomorrow, 11:59. I'm sorry. Yeah, I'll go change it.